What I've got here is an oscilloscope, and an oscilloscope is really a fancy voltmeter. So what I'm looking at is the voltage on this axis and the time on this axis. So it tells me what power supply is doing as time goes by. In this case, I've set it up so that each of these squares represents 1 volt. So this goes from 0 to 5 volts and 0 to -5 volts. And then this axis is showing the time. And at the moment, I've got no voltage at all because I haven't connected the power pack yet. But if I connect the power pack, what you'll see is that the line has jumped up and it's now showing 1.5 volts. So it's halfway between 1 volt and 2 volts. So this is 1.5 volts continuous. It's not changing. And this is called direct current. And it's a continuous current in the same direction. And you can see that at the moment it's 1.5 volts. If I connect it to here, it will jump up higher and it's now at 3 volts. So I've put 2 batteries together in series and I've got 3 volts. And again, it's continuous, it's not changing at all. And so it's staying at the same voltage, 3 volts. If I move it to here, then it goes up to 4.5 volts. So I've now got 3 batteries in series, and that gives me 4.5 volts. If I go back to having it at 0, but this time I'm going to reverse the battery pack, and what I'll see is that the current will go in the other direction, and we've now got -1.5 volts. But again, it's unchanging, so the line is continuous along here. Again, -3 volts and -4.5 volts. But all of these are just versions of what we call direct current, so there's no change in the voltage with time. It just stays the same and it stays in the same direction, always going either forwards or backwards. So what we're now going to do is put it into an AC power supply so you can see the difference between the AC and the DC. So with the DC it was a continuous line, but when I put on the AC, what you'll see is that we have this wave pattern and the voltage is going between in this case +8 volts, so it's peak at +8 volts and going down to -8 volts, but it's continuously changing. If I just pause it on the oscilloscope, so just to take a snapshot of it, you can see that the voltage is going from 0 to +8 volts, back to 0, and then in the other direction to -8 volts and back to 0. So it's continuously changing. We call this alternating current because the current is first going one way through the wire and then it's coming back again. And in fact, this is what we get through the mains power supply. That's how it's sent to people's homes. So the voltage is alternating, and in the case of the homes, it alternates between plus and minus about 330 volts, which averages out at the 230 volts that people talk about, mains voltage being 230 volts. So this power supply is giving us AC. I can vary it, so if I get it running again, and if I lower the voltage, you can see that the voltage is going now between plus and -2 volts, and I can increase it. One thing you'll notice that hasn't changed is the distance between each of the waves, and that's because the time period is set by the frequency of mains, the mains voltage, which is 50 hertz. So there's 50 of these waves every second, and so if I just lower it back down again, so it's now going between plus and -40 volts. And as I say, if you worked out the time, it would happen 50 times in a second because mains voltage is 50 hertz.